Here we are going to solve a geometric problem, that of constructing this triangle ABC, and as usual three things are given to us. Number one, the base AB 120 millimeters and angle A is 70 degrees. The third thing is little unusual. Instead of giving us an extra length or another angle, they have given us the sum of these two sides. And if we label these sides as say A and B, opposite to angles A and B respectively, then we can write this as A plus B add up to 240 millimeters. Let us start with the obvious by plotting the base AB, and then we can also construct the angle 70 degrees at A. Of course, this length I have shown is arbitrary because we don't know yet what is the value of B, so we can't place C here, but it's going to be somewhere on this line. So this is a kind of locus of C. Now let us see why this problem is unusual or difficult. It is primarily because the length that is given to us, A plus B, or this length A to C to B, is kind of folded. It is not along a straight line, and we have only a straight edge in geometry. We do not have, strings or flexible measuring tapes. Otherwise the problem would have been easy. We just measure a length of 240 millimeters of string, attach one end to A, other at B, and then put the pencil in the string to keep it taut and arrive on this line that will be the point C. But we are not allowed to do that. So let's see a way around. And interestingly, the solution is found in physics or optics in a everyday situation where a straight line length is folded but it remains the same. Let us look at that. So imagine you are driving your car here, and right now you are in the driving seat at point A and you are looking ahead, and as you drive on, there is another vehicle that is merging onto the road, and you want to keep track of all such happenings, but without of course looking in that direction. So what do? We use a mirror, which can reflect these vehicles around, and that will give you a image of the vehicle. If you want to know more about how images are formed in flat mirrors, you can click here and look up that clip. But anyway, in flat mirrors, in a nutshell, all the distances and angles in the real world, which is reflected back here, remain the same in this image or virtual world. And therefore the distance of the real vehicle here, the tanker, from the mirror, and the distance of its image from the mirror are the same. So the mirror is kind of bisecting the line joining the object and its image, number one. Number two, all the distances, say like this A here, are going to remain the same. So if we reflect it around the mirror, so let's do that, it's going to exactly land and give us this point here. So you can notice one more good thing that has happened. The distance A, which has remained the same, has now also lined up with distance B, and therefore this straight line distance which is given to us, the sum of them, can be easily plotted. We would be plotting this distance in a straight line, and then we will be folding it around to bring this part of it over here, and that is how we will get it. And where to fold it? How will we know? Well, the mirror is going to tell us. And where is the mirror? The mirror is the bisector of the line joining object and the image. Of course, in our case we don't have these vehicles. Instead we are going to have this point B, and on the other side we can construct its image B dash. Say this is the image B dash. Let us join the line B dash. If you look at these two triangles, say BCM and B dash CM, then one is an object and the other is a image, so they should be identical. This is a straight line, so these two angles add up to 180, so each of them must be 90 degrees. So this mirror is not only passing through the midpoint, but it is also a perpendicular to this line, so it is a perpendicular bisector. So we take the midpoint M here and draw the perpendicular bisector. So we start by plotting the base AB, then construct angle 70 degrees. On that line we expect C, so that is locus of C. On this locus we mark point B dash at the given distance A plus B, 240 mm, so that is B dash. Then we connect B and B dash. find its midpoint, or rather the perpendicular bisector, and wherever this bisector meets this 70-degree line, that is going to be the point C. And once we have the point, we just complete the triangle. So that's the construction.